Welcome back to another video of Chem 101. In this final video on sig figs, I'm going to show you how we do calculations that are multiplication and division, and then we'll tie everything together and include some addition, subtraction, multiplication, division problems all together. Okay, so for multiplication and division, it's actually a much more straightforward rule, and that rule is the number of sig figs in the final answer will be equal to the lowest number of sig figs in the problem. Now that might sound confusing, it's actually not. Let's look at an example. Let's take 4.3 times 118 times 5.00112. Now the answer, according to the rule, is going to have 2 sig figs in it. Now this is because 4.3 has 2 sig figs in it. And since it is the lowest number of sig figs out of the 3 numbers involved, that will determine the number of sig figs in our answer. 118 has 3 sig figs, 5.00112 has 6 sig figs, and our answer, this is what I get out of my calculator, we actually can't keep all of those digits. We only get to keep 2. And so how do we round this number into 2 sig figs? Essentially, we can only keep 2 sig figs. So how do we represent a number with only 2 sig figs that is close to this number? And if you said 2500, good job. 2500 has 2 sig figs in it, and it's basically, it reflects the certainty of the individual numbers in this total problem. So if we have 4.3 times 118 times 5.00112, it's a little unfair to say that all of those multiplied together is exactly, pretend that these are measurements, to say that this whatever we've measured is exactly, 2537.568288. There's a whole lot of certainty there when 2 of our measurements, 4.3 and 118, those don't really have that much accuracy to them compared to that other number. So our answer that reflects the fact that some of these numbers have less accuracy is that 2500 is all we could say. Alright, let's look at a problem with division in it. Let's take a problem like this. 2.5 times 0.01131, all divided by 7051.5. And so our answer on my calculator actually comes out to be a really, really small number. Your calculator might only go out to 0.0000401, depends on what you have. Okay, but that's the answer. Now, how many sig figs can we keep? So let's just identify how many sig figs each of these individual parts has. So 2.5 has 2 sig figs. 0.1131, this has 4 sig figs. And 7051.5 has 5 sig figs. So according to the rules of multiplication and division, 2 being the lowest number, that means we can only keep 2 sig figs. So we would be able to keep out to there. We wouldn't be able to round this at all. Oh, we could put this into scientific notation. That would be 4.0 times 10 to the minus 6, or just 0.0000040. This 4 and this 0 over here being the 2 significant figures. We can look at a different problem. 8041 times 6 times 11.3 divided by 0.01. Let's identify the number of sig figs in each of these. 8041, this has 4 sig figs. 6, that's just 1 sig fig. 11.3, that's 3 sig figs. And 0.01, that is just 1 sig fig. So our lowest number of sig figs is 1. So our answer will only have 1 sig fig. So our answer comes out to be 54,517,980, but we can only keep 1 sig fig, and so we'll have to round our answer down. Well, we have a choice. 1 sig fig can either be, let's see, 50,000, or 60,000. Both of these numbers only have one sig fig in them, and our actual number here falls right in between these two. So we would have to make a decision. Is this going to be closer to 50 million, or closer to 60 million? And actually, since we can only keep that one sig fig, and the number following it's a 4 and not a 5, we wouldn't round up. So the correct answer here would be 50 million, or if we wanted to write that in scientific notation, it'd be 5 times 10 to the 7. 5 times 10 to the 7. So there's our one sig fig right there. Alright, let's try one more problem. This time let's add and subtract as well as multiply and divide, or at least mix the rules for the two together. Alright, let's take a problem like this. I love asking this kind of problem in my chemistry class because students, they'll master one set of rules for adding and subtracting, they'll master the other set of rules for multiplying and dividing, and yet somehow when I couple them together, they can't seem to get it right. Which just means that this is a confusing topic, or this is a hard type of problem, even though it seems extremely simple. Now, what I would recommend for doing problems like this is start off with the right answer. Don't whittle the answer away as you go. Put this into your calculator, get an answer. Alright, put it in my calculator, this is what I get. Now, I like to start off with my answer so that I know that however many sig figs I end up figuring out, it shouldn't be different than this number. And sometimes, and this is the main thing I see when grading tests and things like that, is that students give me answers that aren't even the right answer. They're not even right, because if we have to take this number and we're just gonna cut it off somewhere, right? We're just going to determine some number of sig figs to keep. We'll either keep the 2 and call this 200, negative 200, or we'll say it's negative 260, or we'll say it's negative 269.59 or 58. So it's going to be some part of this number. So make sure that you have the right number. Let's figure out how many sig figs to keep now. Okay, so the way that I recommend doing these is you do the addition subtraction stuff first. So let's just start doing that. So let's combine 18.02 and 187.1 together. Okay, we get negative 169.08. Now remember, this was a subtraction problem, so the number of sig figs that we can keep here is all based on the lowest common certainty. And for both of these numbers, let's see, 187.1 is certain out to the 10th place, and 18.02 is out to the 100th. So we can't keep anything past the tenths. So for this number, this is all we can keep of it. So I want to kind of keep that off to the side there. Alright, so that's negative 169.08, but we can only keep 4 sig figs. Okay, now 4 sig figs divided by 1 sig fig is going to be just right. Now it's multiplication division rules. We can only keep one of those 1 sig fig. So what's negative 169.08 divided by 7? That comes out to be negative 24.1542. We don't have to keep going. We already know we can only keep 1 sig fig. So that means that's all we can keep. From this whole side of the problem over here, from this whole side, we can only keep this 1 sig fig of that answer. So maybe students get a little mixed up when they look at this initially. You might think this has 1 sig fig. Both of these numbers have 4 sig figs, and that's true. Even if we were treating this just like multiplication division rules, we would only end up with keeping 1 sig fig over here. I think another mistake students make is that when they realize they can only keep 1 sig fig, they change their answer to be 20, since 20 has 1 sig fig. But 20 times the rest of this stuff isn't going to give you the same answer as 24.1542 times the rest of that stuff. So don't round your answer too soon. Just know how much of your answer you get to keep. So we get to keep that 1 sig fig there. Okay. So now let's, well, we can kind of keep this to the side. So now let's go over to this other part over here and add these together. Now this is going to be, I could probably do this in my head. Let's see, we're going to get 11.161. And again, the least certainty, or the least common certainty for both of these, is the tens place, right? So we can only keep out to the tens place. So we'll be able to keep 3 sig figs of this number. Alright, so we've got, so I guess we can, now we've got a multiplication problem that we're doing. So it's going to be negative 24.1542, keeping in mind that there's only 1 sig fig, times 11.1161, keeping in mind we can only keep 3 sig figs. So again, we don't want to cut off these numbers and just use 3. We still want to keep all of our numbers so that we can end up with this final answer. So now it's just a multiplication rule, and that's the lowest number of sig figs determines our answer. So since it's 1 sig fig times 3 sig figs, we can only keep 1 sig fig. So we would cut our answer off right there, and we'd say, since the only 2 options for a 1 sig fig answer are 200 or 300, we want to see where this falls. It's 2 with a 6 after it, so it's going to be a little closer to the 300 side. So 300 is our answer to this problem. So let's just go through it one more time and kind of see where those sig figs came from and where they went. We had 4 sig figs here, we had 3 sig figs here, but remember we were adding these numbers together. So those rules are the rules that look at the least common certainty. So we get 3 sig figs. Over here we have 4 sig figs in our answer divided by a number with 1 sig fig. So that gave us this 1 sig fig answer, and so then 1 times 3, or 1 sig fig times 3 sig figs, using multiplication division rules, we're going to end up with 1 sig fig. Alright, so that concludes the videos on sig figs. Of course, this can't cover every possible question or example, but send me some comments or questions, and I'll do my best to make a video with follow-up answers.